So, hello everyone again. I see my colleague over there. I'm going to put a few more. These questions are more or less exclusively from the A2 content. And so as you can see, it's another folder. The starting question is 646. I'll try to put as many questions and answers there for you as possible. As before, uh, as soon as you see a question, pause on it a few seconds. Try to see if you can answer it. Then you look at the answer afterwards. Okay, we've already done this 3 or 4 times in different folders already. So I try to get out of the way just by maybe going, yeah, I don't know, I don't want my head to show. But anyway, here we go. So question, answer. I try to pause in each for 3-4 seconds so you don't panic pausing on them. As you can see, plenty of NMR questions usually get spectrographs and you have to identify. Now, something like that would be very useful too. You'll see where these signals are coming from. I try to color code them for you as well, so they are very, very clear. On a very rare occasion, you might get questions on carbon-13, but the most they want you to know about carbon-13 is that how many lines are there, i.e. how many different carbon environments, different environments are there. So this is different. So it takes you back to AS, 3D structure. With these questions, they would probably ask for 1 or 2 areas in any molecules, because they will not want to give you anything more than 2 marks on 3D structures. Again, back to some NMR questions again. As you can see here, if I may show, on the exam, sometimes these are very, very tiny, but it is enormously important to know how many signals you get from these tiny ones. And sometimes they do exactly that. They blow it up so it's very clear as to how many there are. 1, 2, 3, 4, 5, 6, 7 in this case. And then the answer. Now, you will get questions like this quite regularly, and identification of organic compounds, the procedures involved. But then there may be different approaches. Okay, so and these questions, generally speaking, we are looking at north of 5-6 marks. Chromatography is something we did right at the end. So challenges or difficulties with TLC. this is good practice, but it is very unlikely that they will give you something like this to do. Usually they give you the spectrograph and then you have to identify. But then this is also the other way around. Yeah, this is more like it, and I think this is one of the more challenging ones. A doublet with 6 protons, then you have a quartet, then you have a multiplet, that is 7 signals there, then you have a pentet, and then round about the 6.8 to 8.2, round about 7, you have a signal for organic with 4 protons, 11 carbon, 13 environments, C13H16O2. I think I've put the, where are we? Yeah, it should be here. Yeah, during our lessons, if you remember, or if you're from elsewhere, I've always told my students to, they need to put these data on a tabular format, and for all your inferences, you get 1 mark each. So I don't know, maybe and then this is organic synthesis. Going back to organic synthesis, how would you produce AB from benzene, methane, and ammonia at the bottom, CH4NH3? You need to go back and forth with your, just check your knowledge base. A little bit on module 5 and the transition complex and the idea of colors. First thing you have to do is electronic configuration. A little bit about ionic or compounds with intermediate characteristics, ionic as well as covalency. You may be asked about these things in order to check your depth of knowledge. The idea of charge density always should be on your mind. And if species or ions have very high charge density, so why would that matter? Pay attention to the last sentence at the bottom of this answer. Something similar, lead tetrachloride, lead dichloride. Answer. Again, something on 3D structure. So you do have a few questions from the first year of the course. Right, something on redox titration, but this one is with thiosulfate. And remember, the procedure with thiosulfate is that you get a piece of brass or copper, you react it with concentrated nitric acid, you take the solution, you make it up to 250, you take 25 milliliter out, you put it in a flask, to which you add potassium iodide as a source of iodide. Then the solution will turn brown because it produces iodine, and you get a white precipitate because you produce copper 1 iodide. And then it is iodine that you titrate against thiosulfate. Yep. And then towards the end, as thiosulfate is removing iodine more and more, the solution becomes paler and paler, and towards the end you add a few drops of starch to identify presence of iodine. This procedure is usually the same for all the questions that you are given. And this one is a 5 gram of 90% pure. So I've tried to structure it slightly differently. On this occasion, you have to find out what the concentration of thiosulfate is. They can play it whichever way they want, but the procedure is, as you can see, for each of these equations and arriving at the fact that the ratio is 1:1 is something that you have to arrive at, because some of you already know that that is the ratio, but that will not do. So the answer is, seemingly from the question that I made up, is 2.8 moles per decimeter cube. This is a redox reaction in which potassium permanganate is used to oxidize vanadium nitrate to vanadium 5+. If that is the case, then what is the concentration of vanadium nitrate that you used? The procedure for these are much simpler than when you're using thiosulfate. But again, everything starts from equations and balancing the equations. By balancing, I mean balancing the number of electrons gained and lost. And therefore you arrive at the equation. And then you realize every 3 moles of permanganate reacts with 5 moles of vanadium. You know how many moles of permanganate you've used. You multiply it by the ratio, multiply by 5 over 3. And therefore the solution, ultimately it is what it is. 0.4 mole per decimeter cube, because what I wrote on the previous page wasn't very clear. So you got 0.01 mole in 25 milliliters, so how much would you have in 1000? Don't forget, concentration is moles per decimeter cube, not moles per 25 cubic centimeter. So you have to ratio it up. And then this one, expectedly, is another question. Here we're using acidified dichromate. So you got questions on permanganate, dichromate, as well as thiosulfate. And you're using 80% pure iron. So what mass of iron did you use? Again, in any calculation in chemistry, as you would know, you have to start writing the equation. Again, iron goes from iron to iron 3. Chromium goes from chromium 6 to chromium 3+. And therefore you write the equation, number 3, to find the ratio. Every 1 mole of dichromate reacts with 2 moles of iron. So we know how many moles of dichromate we have used. The ratio is 1 to 2, therefore you multiply it by 2. This is the number of moles of iron that we must have used. You simply multiply that by the MR of iron. But remember, it was 80% pure. So the original mass is 100 times 80, 0.5, which is the impure mass of iron. 3.39 gram is pure, but then there was another 20% impurity on top. Yeah, so multiply by 100 divided by. I think this video is becoming a little bit too long, so last question, whatever it is. Right, and that's a very nice question as well. Again, this is to do with thiosulfate. Remember, whether this is sodium or potassium or lithium, it doesn't matter. It's a thiosulfate that matters, and the procedure is always the same, like I explained to you earlier. You must write these equations for each of these things. You get marks. Must not omit them, because ultimately you have to show how you have arrived at a 1-to-1 ratio. And then the calculation is pretty simple, straightforward, like acid-alkali calculation you did before. Okay, I think that would do for this. Plenty of very, very good question. If you know all of these things, if you can practice them and if you know them, they will add a lot of marks to your papers. Okay, thank you.